Hey, fellow mathers! Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! Welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And you've found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do. But y'all, it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor mathematicians as we co-create meaning together. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be.
In today's episode, we're going to discuss a common sticking point for many teachers and students.
Let me tell you. So teachers early on, when I very first, I dove into the research, I dove into my kids' classrooms. I was doing a lot of experimenting. I was reading all this stuff, trying activities. I started doing professional development with teachers. And so then teachers were coming out of the woodwork. They're like, okay, so you're kind of entertaining. It's, we're learning stuff. This is good. They started asking me for things. And one of the things they asked me for really early on was, okay, all right, Pam, next professional learning, we want you to teach us how to do rounding. And I was like, huh? I was like, how do you teach rounding? I don't know. It was so like, I had no idea what that even, because then they would say, it so floored me in part because then they would say, well, yeah, like we've tried. And then they would list these things. And I was like, oh, not that. Because they would list these crazy rules or colors, rhymes, directions, all the steps. Like I just, in the intro, I just said, rotely repeating steps actually keep students from being the mathematicians they can be. This was because teachers would say, well, I've tried this one. 4 or less, let it rest. 5 or more, let it soar. Or one of them was 4 or less, let it rest. 5 or more, up the score. Because, like we're scoring things. One of them was 5 and above, give it a shove.
Oh, no.
They were showing me things about, so you underline this number and you circle the one before. They had these arrows to shove, and they had or arrows to soar. I saw one with wings. Kim, it was all now I get it. If you are the teacher who learned math as fake math, and so it's all about steps and procedures, and you're going to help those kids learn those steps. Well, if it is, then you're going to try to make it fun and cute. And y'all, if you look at something about teaching math and it looks cute, may I just respectfully suggest it's an attempt to make fake math palatable. It's an attempt to make fake math rote memorizable. In other words, fake math alert. That's a fake math alert. Can we actually reason about relationships? So it's another time where I went up to you and I was like, Kim, how do you teach rounding? And you were like, duh. You're always so cute because you would just look at me like, well, the only way that a sensible person would. And I'm like, okay, tell me what that, tell me what that way is. Tell me what that sensible way is. So Kim, I'm going to let you fly. Tell me about rounding.
Well, so just like we talked about in last week's podcast episode, I found such power in when you shared the open number line with me. And I'm super grateful because while I was messing with numbers in my head, I didn't really have the best ways necessarily other than just talking at my students. I didn't have the best ways to help them visualize what was happening. I didn't have a great way of recording things that were happening.
Really
But
making
wow.
that thinking visible.
Yes,
Yeah.
absolutely. And so,
Yeah.
when you came to me saying like, what about rounding? It was a natural thing for me to say, oh, you would just put it on a number line because that's kind of where numbers are, right? Like I have this visual in my head of a number line now. And so numbers have relationship to each other. And so, if you were to ask me like, say 53, if you were going to ask me where does 53 fall in relation to other numbers, then I would sketch a number line. I would put 53 down, and it was an opportunity for me to say, where does 53 fall? Oh, it's 3 away from 50. And I
And
would make a
you're asking students this, right?
well, I'm just telling you what I would do in my head, and then this
Ah,
is
okay.
this is
Sorry.
kind of the
Sorry.
conversation I have with myself, but the same conversation I'd have with students. So if we're trying to figure out where 53 is and which 10 it's closest to, then the question is, how far away is it? So the first thing that I would share is that I think about which 10s it falls between. And so 53 falls between 50 and 60. And so whichever one it's closest to is what it would round to. And so 53 is only 3 away from 50. So I'd make a jump of 3 backwards to get to 50. And then I would say, how far away is it from 60? And it's 7 away. And so naturally, it's closer to 50.
Mm-hmm.
And so
Mm-hmm.
it would round to 50.
Nice. If you're
Yeah.
rounding to the nearest 10.
Right.
So what if we round to the nearest 100?
So same thing, I would put 53 down on a piece of paper and I would say, oh, it's between 0 and 100.
What hundreds is it between?
Yeah.
Yeah.
And so then I would say it's 53 away from 0 and it's 47 away from 100.
Mm-hmm.
And so 53 is closer to 100 than it is to 0. It's all about where it is on that number line. And as I modeled and as students got better with considering those numbers, I also found that their jumps on their number line got nicer, got more in line
Precise.
with proportional. Yeah.
Yeah.
More
Yeah.
precise. That's a good
More
word.
reasonable. More.
Mm-hmm.
Uh-huh. Yeah. More
Mm-hmm.
realistic.
Yeah. Yeah.
All those words. What's interesting, Kim, is as you talking about this, I'm actually kind of acknowledging in my head that you're actually asking more of students in some ways
Yeah.
than,
Yes.
especially if you're just like repeating this rote memorized rhyme, but you're actually asking them how far was 53 from 50 and how far was 53 from 60
Yes.
and correspondingly how far was 53 from
Yes.
0, how far is it from 100? Well, bam, I have you need. Like those partners you're actually asking students to figure out more than we typically do. If you just say, hey, round to the nearest 10, students could just, think about which one it's closer to, but not actually find the differences. And so you're actually asking more. That's interesting. I think it's sometimes teachers will say to me, like, wait, you're really telling me not to spend 6 weeks on place value? And I'll say, yeah. Do this work that we're suggesting. Because if you do like what Kim just suggested, y'all, notice the place value that's coming out. It's not just a bunch of rhymes about what did I can't even remember. Shove him down, give it a shove, let it soar. It's not what rule, what rhyme to apply. No. It's like we're diving in. We're thinking about place value. What tens is this number closer to? What hundreds is this number? In fact, we could get crazy and say around to the nearest 1,000. Would you similarly then say 53 is what are the thousands?
Yes.
On either side? So can you run us through that? What are the thousands?
So 53 comes between 0 and 1,000. So it's only 53 away from 0. And it's going to be 947 away from 1,000.
From 1,000. Yeah.
Mm-hmm.
Look at that extra work that she's doing. Isn't that brilliant, y'all? If we can get our students to start thinking that go ahead.
There's such a richness to number that I think sometimes we miss opportunities to give kids those experiences, right? We're constantly talking about experiences. Here's an opportunity for kids to get a really good feel for the richness of 1,000 and where numbers fall.
Yeah. And like you said, their placement on a number line gets better, gets more efficient, gets more precise. Not that that's not what's important, but that what's important is their sense, their perception, their intuition for number. And here's a brilliant way for us to save all that time that we're practicing the rhyme, and can they implement the rhyme and the rule and the color and all the things. And instead we're diving into actually the relationships. I think this is such a good example of, like you just said, the experiences, the richness that we can just keep kids simmering in. I'm just, my
Mhm.
hands are kind of like I'm stirring a pot. Like we're just keep them going in thinking about real math. All right. So somebody out there is thinking about the fact that what I didn't give you was the number 50,
Oh,
right? Or the
yeah.
number 55. And
Yep.
so like, tell me a little bit about, what do you do with, like, if it was instead of 53, what if it was 55? How do you know?
So if it was 55, then it's going to be 45 away from one of the tens and 55 away from the other 10. But what's really tricky for kids is when it is exactly in the middle.
Well, and so what if I said 55 to the nearest 10?
Oh, I thought we were back on hundreds. Sorry about that. So
Yeah, no,
yeah,
you're good. You're
yeah,
good.
that's definitely an interesting conversation to have, right? I love this conversation because we get to talk about the fact that it's both 5 away from 50 and 5 away from 60. And so instead of your rhyme about giving it a shove, it's a really nice chance for me to go, "Oh wow, you're
What are you
right.
going to
It
do?
is exactly in the middle of 50 and 60." And like it's an opportunity for conversation and for kids to go, "Well, like I think that it's we should round down and I think we should round up," and like context for when you would want it to be rounding down or rounding up. And then I get to share that piece of knowledge that's social that I say, mathematicians have just decided that when it's right in the middle, then we round up.
Yeah, when you said that, we just decided, you didn't mean just now. You
No,
meant
no,
like,
no, no, no.
yeah, yeah. Like
They have decided for us.
that is a thing. That is a
Mhm.
thing that mathematicians, and we have to make decisions
Yep.
sometimes like that, and so we call that social knowledge, like you said, and they just decided. But brilliant to have the conversation. And oh my gosh, I loved when you just talked about context. That there are times when the context determines if you're going to round up or down, right?
Yeah.
Like
Yeah.
brilliantly.
Yeah.
In fact, can you? I'm going to put you on the spot. Can you think of a context where you would not round 55 up? Or one that you would round
Where
up,
I
either
want it
one.
to round down
Yeah.
when it's a bill I owe.
Yeah, but you can't. I mean,
I
you're
know.
still gonna have to pay. Can you think of one where you actually would round down? I can.
Um,
I
Go
think
for it.
so.
Yeah, go for it. I'll think some more.
Help me fix it if this doesn't work, because this is off the cuff here. So if I'm looking at purchasing something for $55, but I've only got 50. That's, I don't know. Help me fix it. Something like that, where I'm like, can't get that. Like, I'm not going to round up in that case. It's not 60.
Yeah.
It's close to the 50 I've got, but I can't. It's not perfect. There's got to be a
Yeah.
better. It's got to. Well, y'all, you can tell we
I
record
was
these
going to say
podcasts live.
we should have people send us in an opportunity when you
Oh,
would
let's
want
do
to
that.
bring.
Yeah, you're like screaming at you're all listening to this podcast. You're like, Pam, obviously this one. Here's a good example. Hey, send us your good examples of when you would naturally want to round down
Yeah.
or
I bet we'll
need
get a
to
couple
round
of good
down.
ones.
Yeah, even though it's 5 or above.
Yeah.
And so the rules is to round up, but yeah, you
Yeah.
wouldn't. Oh, I know there's a few. I just can't think of what it is right now. All right, if you can think of one the rest of the episode, that would be cool. Hey, you've talked to me a little bit about clothesline math, and we've done some work with that. Tell
Yeah.
us more about that.
Yeah. So in a variety of grade levels, I have been in classrooms and have done a little work myself with the idea that when you're trying to build intuition about number and relation to other numbers, there's some really great activities where you have a clothesline that spreads across the room and you put like say you give kids a card that has like 7 or 10 or 6 or 5 or 4, and you say, I'm going to put the 0 and the 20 in the beginning and the end of the clothesline. And kids come up and they place numbers where they think it would go on their clothesline number line.
Mm-hmm.
And then they place numbers in relation to each other. So like the 10 kid might come and put the 10 right in the middle. And then other kids place their numbers around it. And it just, as we were talking about rounding, it reminds me that those ideas about placing numbers in relation to each other are absolutely related to rounding, because numbers are in relation to each other.
Because they're all relation. Yeah.
Yeah. And so you can then say, like, what if my number line went from 0 to 10, or whatever the numbers are that
Mm-hmm.
you're going to change, but you give kids experiences coming up and moving numbers around and shifting so that they can see them proximity to each other.
Well, one of my favorite ways of doing that is, let's say that you did your 0 and 20. So you might say, okay, so here's 0 and here's 20. And then you might give kids the number 30. And so
Mm-hmm.
if they had put 0 and 20 at the two ends of the thing, they're going to have to move that 20
Yeah.
to be able to get the 30 on the end. And then you might give them 100. And then they're going to have to shift that 20 and that 30 down in order to put the 100 on the end. And then you might give them 50. And that might help you like kind of judge how the 20 and 30 are fitting with the 50. And then you can start talking about rounding in the midst of that conversation. So again, another really rich place where we get place value and relationship. And you could also drop rounding. I wanted to ask you about that, because as we were talking about 53, I wonder if you put 53 on the, and it doesn't have to really be a clothesline. It could be any kind of like, but rope or string or something. We've seen teachers with really strong magnets, and they sort of put the magnets and then the string, and then use index cards and
Yes.
fold the index cards in half. And that's what you write. And then be really nice to laminate some of those index cards, because then you can change the number. You don't have to like waste index cards. But if you did that with the 53, we could say, all right, y'all, here's 53. Put the tens that are closest to it. So then some kid goes up and puts 50 and somebody puts 60. And then we talk about how they do. And then what you said, the differences, right?
Mm-hmm.
And then you could say, okay, so now I want to put the closest hundreds. Where are those? Well, whoa. Like depending on where they put that 50 and 60, they might have to squish those way in order to get the 0 and the 100 up there. And then, where should 53 be closer to the 0, the 100? And like you said, and then if you are putting those magnets against a whiteboard, you can be actually drawing in those differences that you were talking about.
Mm-hmm.
And then you could say, okay, cool. Now we want to put it, where are the thousands? What thousands is it as close to? Well, now you're like sucking all those in. So in order to get them in, and you might have to even take some off if they're not going to fit, to get them into those closest thousands. And we sort of get this collapsing number line a little bit where you're sort of zooming in and zooming out. And again, brilliant ways to help kids really think and reason, gain relationships. Yeah.
I like it.
Hey, when you were telling me about rounding, there was a point you said something about easier.
Yeah.
And, can you say a little bit more about that?
Sure. So when you have a number like 53 that you're going to put on the number line, I think it's a whole lot easier for kids to say, well, I know that it's 53 away from 0. So going to the lesser 10, the lesser 100, it's easier for them to say it's only 53 away. But finding the greater 100 or the greater 10 requires a little bit of addition or subtraction, right? It's a little bit more thinking involved to find that greater number, which I think is why I did it. Anytime we get a chance to do a little bit extra in there.
And maybe let's get specific. So if I said round to the nearest 100,
okay,
with 53, you're like, well, duh. 53 is 53 away from 0.
Yep.
But in order to tell how far away 53 was from 100,
you had to do a little work.
Do a little work. And if you played I Have You Need, you could be like, well, that's got to be 47.
Yep.
There's that partner. So you're saying it's the when you said the lesser is easier. So like if I said 53 but round to the nearest 1,000.
Yep. So
0. Yeah, go ahead. Keep going.
0 is only 53 away. There's not a lot of work there. There's not a lot of it's that far away from 0. But to get to the 1,000, the number, the 10 or 100 or 1,000 that's greater, then there's definitely some thinking involved. You have to figure out that it's 947 away.
I wonder if that's when I Have You Need was born. I wonder if you were doing rounding and you said to yourself, man, these guys need that relate. They don't own these. They need those. Let's see.
That's a great question. I don't know.
We might have just discovered the birthplace of I Have You Need. Dun, dun, dun.
I'm not sure.
So y'all, when you're rounding, don't just round. Like do it as a part of the rich experience of helping students really learn all of these numerical relationships that will keep them in good stead, that will serve them so well with everything else that we're doing. So thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figure-outable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figure-outable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.